Hello and welcome to our 10th video. My name is At-Tayyib Abul Yemen. This video is intended as a review of two important relationships that I feel would be interesting to revisit. One of the relationships is between the slope of a linear function and the line that's perpendicular to it. The second relationship will be between the linear function and the angle adjacent to it. First, I will start with the relationship between the linear function and the angle adjacent to it, and then I will prove the mutual relationship between the linear function and the line perpendicular to it. To set the stage, let's just first of all, our title for this is the slopes of perpendicular lines, where a linear function is a line. If the slope of a linear function f of x is m, then the slope of its perpendicular g of x is the negative of the reciprocal of m. This is a well-known theory in calculus. Proving it is just gonna give us the satisfaction. So let's go ahead and first of all assume that when I use an arrow, the right arrow, I mean implies. So it's used as a symbol for implies. And in our way to solving or proving this hypothesis, we're going to use an angle. We're going to call it theta. That angle is like 30 degrees. So to get going, we will set the context, which is our xy, and then a circle. The circle will have radius that's equal to 2, and for that reason we're going to go ahead and document radius for the circle is 2. Our next point is also to draw a diameter for the circle, and the diameter, we're going to connect one end of the diameter, we're going to connect it with the x-axis using a vertical line. So this angle is going to be equal to 90 degrees. Now we can identify theta that we want, and theta is the angle that we're assuming it's 30 degrees angle. So this will be the hypo, and this will be the opposite for theta, and this will be the adjacent for theta. To find the slope of this line, which is the linear function we're talking about, to find the slope of this line, we need to know the opposite and the adjacent, because the slope of it is equal to the tangent. Tangent is opposite divided by adjacent. But unfortunately, we don't know the value of any of these two. The only thing that we can figure out here is the hypo. We know the hypo is radius, and we're told the radius is equal to 2. So we know the hypo. But fortunately enough, we also know the value of theta is equal to 30. And since the value of theta is equal to 30, then sine theta will be equal to 1/2. So if sine theta is equal to 1/2, sine theta is the opposite divided by the hypo. If the opposite divided by the hypo is 1/2, and we know the hypo is 2, then the opposite must be equal to 1. So if the opposite is equal to 1 and the hypo is equal to 2, then the adjacent must be equal to square root of 3. So now we'll be able to figure out the tangent of theta. This is 1, this is square root of 3. So the tangent of theta will be equal to 1 over square root of 3. 1 over square root of 3. Of course, this is the point where the opposite and the hypo meet is square root of 3 comma 1, and the point where the opposite and the adjacent meet is square root of 3 comma 0. Now we will identify this line, the hypo. We're going to identify it as our function f of x. It has a slope m1, or we just use m for short, x plus b. This is the general equation for it, would be 1. Since this line, which is the hypo, passes through the origin, then it is y-intercept b1 equal to 0. So the equation for it, general equation for it, will be f of x equal to m multiplied by x. And that's what we have over here. So since b is equal to 0, then f of x equal to m multiplied by x. But one thing we know is that for this function f of x, this is one of the solutions. So if we look at the value of the function at x equal to square root of 3, the value of the function is equal to 1. And we can use these values and plug them over here. So it follows that 1, which is equal to f of x, equals to m multiplied by square root of x. Like we said, when x is equal to square root of 3, f of x will be equal to 1. So we have 1 here, and we have square root of 3 in place of x. Now we can solve this problem, or we can solve this equation for m. So our m will be equal to 1 over square root of 3. Interestingly enough, that the slope 1 over square root of 3 is equal to the tan of the angle adjacent to it. So we can see that there is this relationship we took for granted, and the tangent of an angle is really the slope of the line that's adjacent to the tangent. Now that we've done this one, our next stop is to go ahead and determine the line that's perpendicular to the hypo, or perpendicular to f of x, which is g of x. And we have to show that the slope of g of x is the reciprocal, the negative of the reciprocal of the slope of f of x. Since the slope of f of x is equal to m, then we have to prove that the slope of g of x will be equal to the negative of square root of 3. But before we do that, we have to identify where g of x is. So to do that, we're going to go ahead and connect the point square root of 3 comma 1 with a line connected to the y-axis. This line will be parallel to the x-axis, and for that reason this angle will be equal to theta, which is equal to this one. So that angle is equal to theta. Now we draw the line perpendicular to the hypo, and this line we know that intercepts the y-axis, and also it meets the x-axis. So the angle between this line and the y-axis is equal to theta, for the simple reason that if we look at the point square root of 3, 1, the angle is 90 degrees, because this line and this line are perpendicular. So for that reason, if this is theta, this will be 90 minus theta. But this is a right angle triangle, so if this is 90 minus theta and this is 90, this must be equal to theta. So now that we know that this particular angle is equal to theta, we want to look at the opposite of this angle and how much it is. The opposite of theta is this line, but we know that this line, it's like square root of 3. Its length is square root of 3. So if we know this line and know its length square root of 3, then we want to also try to use the same approach to find tan theta for this theta. We already found tan theta for this theta. We want to find tan theta for this theta, and we know tan theta is equal to 1 over 3. So 1 over square root of 3, then this theta should also have tan that's equal to 1 over square root of 3. But we know the opposite for this theta is equal to square root of 3. So if the opposite is square root of 3 and we don't know the adjacent, we're just going to go ahead and list tan theta as the opposite, which is square root of 3, divided by the adjacent, which we don't know its value for now. So we just put the adjacent. But like I said, tan of this theta, the black one, is the same as tan of the red one. For that, we can just use the advantage of the equality of the tan for both of them. Since the right hand side is 1 over square root of 3 to the black theta, it should be the same also. So this ratio should also result in 1 over square root of 3. And for this to result in 1 over square root of 3, the adjacent must be equal to 3. So if the adjacent is equal to 3, then we know that we have from this point 0, 1 to the y-intercept of g of x, we know that this is equal to 3 in length. But also from 0, 1 to the x-axis is 1. So the total is 4. That means the y-intercept for g of x is 0, 4. It intercepts the y-axis at y equal to 4. So now that we know this information, we could go ahead and say g of x has a slope m2, we call it, but in general m, x plus b. This is the general formula, and from this we can also tell that b is equal to 4, because b, it is y-intercept, is equal to 4. And since b is equal to 4, we can plug in for g of x to be equal to, generally speaking, mx plus b, which is right here. So g of x, because b is equal to 4, then g of x could be written as g of x equal to mx plus 4. Now that we wrote this one, we can go ahead and also use the point square root of 3, 1. And since this point lies on g of x as well, then we can evaluate the value of g of x, g of square root of 3. G of square root of 3 is going to be equal to 1 for us. So we can go ahead and say g of square root of 3 is equal to 1, so we'll put 1 over here. Equals to m multiplied by x, replace x by square root of 3. So if that is the case, we can see that 1 is equal to m multiplied by square root of 3 plus b, which is 4. We could go ahead and take 4 to the left hand side. It will become minus 4, negative 4, and we add 1 to it, it will be negative 3. So negative 3 will be equal to m multiplied by square root of 3, which is right here. Negative 3 is equal to square root of m multiplied by square root of 3 multiplied by m. Now we can do the math to go ahead and figure out what is the slope by dividing this side by square root of 3 and this side by square root of 3. If we did the math, then we will have the left side equal to 3 divided by square root of 3, the negative, we keep the negative sign, equals to, is going to be equal to, here we have square root of 3 multiplied by m, so we divide by square root of 3, we be left with m. So m is equal to negative 3 divided by square root of 3. And that we could reduce it to square root of 3, square root of negative square root of 3. And we just said that the negative square root of 3 is satisfying the hypothesis. Our hypothesis, we assumed m to be equal to 1 over square root of 3, and we said that the slope of the perpendicular will be negative of the reciprocal. So the reciprocal of this is equal to square root of 3, and it's negative square root of 3 over here. So that proves the theory. Thank you for watching, and you have a good day.